Hello friends, we have covered up to this hop limit. We have covered now the source address. Source address, in order to communicate between source and destination, we need to provide source address and as well as destination address. Source address is how many bytes? 128 bits. 120 bits means it is 16 byte, and destination address is also 128 bit, right? With this 128 bit address, how many IP addresses possible? IPv6 address possible? 2 to the power 128 IP addresses possible, right? Now I will discuss the traffic classes, right? I'll discuss the traffic classes. I'll discuss the traffic classes. Right? Now, whenever a router is congested, it does not have any space to accommodate packets, then it has to discard some of the packets. How it will discard? Depending on the sum of the priority. Yesterday I told this priority traffic classes, basics about now I'm exploring these priority and traffic classes, right? So whenever a router is congested, it does not have any space. It has some buffer. If the buffer cannot accommodate the packets, then this router has to discard some of the packets. How will discard? Depending on this some priority value, right? Now the packet with least priority will be discarded, and the traffic, we can divide the traffic into two types. We can divide the traffic into two types. One is congestion control traffic. Another is uncontrolled traffic, right? In congestion control traffic, the protocol which transmitting the data, they will observe that some congestion, they will automatically reset their window sizes. In congestion control traffic, the protocol which is transmitting the data, they will observe some congestion, then they automatically resize or they automatically set their window sizes. For example, all the data or traffic coming out of TCP has the capacity to understand the congestion in the network by using congestion control. If there is some congestion in the network, then the TCP will adjust itself. TCP will adjust the window according to the congestion window, right? The TCP will adjust its congestion window. If there is some congestion some congestion happens at a network, right? But there are other protocols which do not have the capacity to understand the congestion. Means in case of congestion control, some protocols can understand the congestion, but there are some protocols which have not the capacity to understand the congestions. These are called uncontrolled. I have told there are two type of traffic can be classified into two types. One is congestion control traffic and another is uncontrolled traffic. In case of uncontrolled traffic, some protocols which do not have the capacity to understand the congestion, these are called uncontrolled, right? So among this congestion controlled traffic and uncontrolled traffic, which one is having more priority? Now we have to give this uncontrolled traffic as higher priority and congestion control as low priority, right? Low priority. Now the software is written in such a way that it can understand if a packet is lost, it can be retransmitted. In case of congestion control traffic, mean in case of congestion control traffic, the software written in such a way that it can understand the congestion, and in case of if a packet is lost, then it can be retransmitted. Congestion control means it can understand the congestion. Uncontrolled means it cannot understand the congestions. So in case of congestion happens, if there is a congestion in the network, if a packet is lost, then it has to be retransmitted, right? But in case of uncontrolled traffic, the software is not written so intelligently so that it can understand the congestion. But in case of uncontrolled traffic, we do not want the packet to be discarded, right? For example, audio video. If this audio video traffic is being sent, right, if the router discards some of the packets of audio video, then what will happen? There may be discontinuity in the audio or video if some of the packets is discarded, right? In case of audio video, for example, we can take that suppose we are watching some live streaming, like we are watching suppose live streaming of cricket match, right? Suppose if there is a packet loss, then what will happen? There will not get the continuous video, right? There may be a discontinuity in the live streaming, right? So we always want that the packet should not be discarded in case of uncontrolled traffic, right? Now, but in case of congestion control traffic, suppose if you send a file using FTP, if you discard a packet, later you can retransmit it, right? And that packet will be kept in place and a file be formed, right? Now, in case this, I have told you that priority or traffic class is of 8-bit length. This 4-bit meant for setting the priority value, and this 4-bit is under research now, right? And with this 4-bit, how many values possible? 0 to 15 value possible. And among these 0 to 15 values, 0 to 7 values, this is meant for congestion control, right? And 8 to 15 meant for uncontrolled. 0 to 7 traffic is still of two types. One is congestion control traffic and another is uncontrolled. So 0 to 7 priority value is set meaning meant for congestion control, and 8 to 15 I have told you that uncontrolled traffic will be given more priority than the congestion control traffic. That's why these are having higher priority on controlled traffic, right? And see, this 0 to 7 is meant for congestion control traffic. Here here is a table. See, this is a priority and its meaning. See, note it down this table. The priority 0 meant for no specific traffic, 1 meant for background data, 2 meant for unattended data traffic, 3 meant for reserve, 4 meant for attended bulk data traffic, 5 meant for reserved, 6 meant for interactive traffic, 7 meant for controlled traffic. Right? Now, no specific traffic means what? No specific traffic. What is its priority value? 0. 0 means what? Least priority. This is least priority. This is least to high. This is low to high. Right? Like this. Low to high. This is low. This is high. Low priority to high priority. 0 is having low priority. That means no specific traffic is given as low priority, having value 0. So when a packet with priority value 0 is reached at a router, then the packet will be that priority with least value will be discarded. Right? Next is background data 1. Priority value is 1. 1 means whenever a process is sending data, then another other process is running receiving data. Whenever a process is sending, suppose sender is sending data to receiver. Whenever a process is running, sender process is running and other is receiver process is running, and both the processes are running in background. This is called, even if the data is lost, it can be retransmitted and made available. Right? Third is unattended data traffic. Third is unattended data traffic. What is first? What is attended? Attended means someone is sitting with the systems and wants the data is called attended. Someone is sitting with the system and wants the data is called attended. Unattended means no one is sitting there and can be received the data at any time. Are you getting my point? For example, email or email data. Email data attended or unattended? Tell me. This is unattended because you are not always sitting with the systems. It is unattended. Right? Now, next is reserved. This reserved we should not discuss it because reserved field is meant for future purposes, future use. Right? Next is attended bulk data traffic, whose priority value is 4. Attended bulk data traffic. Attended, I have told you that attended means someone is sitting with the system and wants the data is attended. That means, so in this case some user is waiting for data to arrive, so it has to be given higher priority over email. For example, FTP, downloading the file and waiting for the file. Right? Another example is HTTP traffic. Suppose when you are browsing like google.com, you are typing and you are waiting for the web page to arrive. That means you are waiting for the google.com to respond and display the Google page to you. You are waiting for that. This is called attended bulk data traffic, and it has higher priority over email because you are attended. Right? You are attending the data. Next is reserved, whose priority value is 5. Right? And it will not be discussed because it is meant for future uses, future purposes. Next is interactive traffic. Interactive traffic means someone is interacting with the server. For example, remote login. So you can say that remote login, what will happen? Now, because of higher priority, remote login can be given as higher priority because of SNMP. What is SNMP? What is SNMP? Now, SNMP is Simple Network Management Protocol. Suppose if a routers are getting SNMP packets. What is SNMP? Means SNMP packets are meant for managing the network, right? If you keep on discarding the SNMP packets, then you cannot manage the network. So that's why these packets to be given as higher priority, right? Now up to this we have covered this 0 to 7 for meant for congestion control traffic. Next we will discuss uncontrolled traffic, right?